OpenAI is making its own silicon. Anthropic's latest model may have cracked classified government systems, and the AI talent war is bleeding Google dry. We are breaking down the biggest stories you need to know about right now, plus the deep technical takeaways that actually matter. Let's get into it. First up, OpenAI is officially in the hardware game. The company has revealed its first custom processor, an ASIC codenamed Jalapeño. This isn't just a side project, it's a strategic partnership with Broadcom, a giant in semiconductor design. The key detail here is that Jalapeno is purpose-built for AI inference. This tells us exactly where OpenAI's priorities are, driving down the operational cost and latency of running their massive models like GPT-4 and beyond. This isn't just about cost, though. It's about latency and power efficiency. For a real-time service like ChatGPT, every millisecond counts. A custom ASIC can be designed with a memory architecture and data pathways that are perfectly suited to the specific transformer architecture OpenAI uses, minimizing the data movement bottleneck that plagues general-purpose GPUs in inference scenarios. Think of it as the difference between a Swiss Army knife and a surgical scalpel. NVIDIA's H100 is the ultimate Swiss Army knife, brilliant for training and flexible for inference. Jalapeno is the scalpel, designed for one job, running OpenAI's production models, and doing it with extreme efficiency. This move mirrors what Google did with its TPUs and Amazon with Inferentia. The hyperscalers are all building their own silicon, and now the AI native leaders are following suit. For investors, this signals a long-term play to reduce dependency on NVIDIA and slash the single biggest line item on their P&L, compute costs. For engineers, it's a clear indicator that the future of AI at scale isn't just about bigger models, but about co-designing hardware and software for maximum efficiency. Next, a story with significant national security implications. An anonymous source claims that testing by Anthropic's Mythos model has uncovered security vulnerabilities in classified U.S. government systems. Now, let's be clear. This is from an unconfirmed source, but the implications are too significant to ignore. The report suggests that advanced AI, designed for benign tasks, can be repurposed for sophisticated security auditing and, potentially, offensive cyber operations. This highlights the classic dual-use problem in AI. But how would an LLM even do this? It's not just running a script. It's about ingesting massive amounts of documentation, source code, and network architecture diagrams, data that is often unstructured and in disparate formats. The model can then build a cognitive map of the system, identifying logical inconsistencies, flawed access control policies, or subtle bugs in custom code that a standard scanner would miss. For example, it could correlate a comment in a legacy codebase with a specific firewall rule configuration to identify an exploitable pathway. This is a level of abstraction that is incredibly difficult for automated tools and time-consuming for human auditors. While we must stress the unconfirmed nature of this report, it aligns with DARPA's own AI Cyber Challenge, which is actively seeking to use AI for this exact purpose: automated vulnerability discovery and patching. Our third top story is about the most valuable resource in AI: talent. The exodus of top researchers from Google continues, with Jonas Adler and Alexander Pritzel being the latest high-profile departures, both heading to Anthropic. This isn't an isolated event, it's a sustained trend. Why is this concentration of talent so important? Because a small number of elite researchers can have an outsized impact on the trajectory of the field. Think of the original "Attention is all you need" paper from Google. 8 authors who changed everything. When you gather a critical mass of people who have defined the state of the art, you create a flywheel of innovation. They attract other top talent, they challenge each other, and they can move much faster without the bureaucracy of a company that also has to manage a search engine, a cloud business, and an ad network. For Google, the risk is not just falling behind in capabilities, but a slow erosion of its identity as the world's premier AI research institution, a title it has held for over a decade. This isn't just a personnel issue, it's a strategic threat for the company. Let's zoom in on 2 developments that signal where the cutting edge is headed. First, a new paper from OpenAI confirms what many of us are seeing in practice. AI agents are getting good. They're successfully executing longer, more complex, multi-step tasks, moving beyond simple Q&A to become genuine workflow automation engines. But the really novel application comes from Princeton. Researchers there are using a combination of reinforcement learning and diffusion models to automate the design of radio frequency integrated circuits, or RFICs. This is a notoriously complex, non-intuitive field. The AI-driven approach is not only slashing design times, but is achieving record performance for wireless technologies. This is significant because it shows the power of these models extending far beyond language and images into the hard engineering disciplines. It's a proof of concept for AI-native engineering, where the design space is explored by an algorithm, not just a human. Now for a quick roundup of other key stories. First, AI chipmaker Cerebras saw its stock plunge after its first earnings report. The market reacted poorly to a forecast of narrower gross margins, despite the CEO's claims of a misunderstanding. Second, AI money is flowing into politics and entertainment, and not everyone is happy. A $27 million proxy war by AI backed super PACs failed to win a New York congressional primary. And Google DeepMind's $75 million investment in indie film studio A24 has sparked backlash from fans worried about AI's creative influence. Finally, for developers, Figma has rolled out new AI tools for motion graphics and shaders, embedding agents directly into the design canvas. So, what are the key takeaways from all this? For engineers, pay attention to the trend of custom, vertically integrated hardware. OpenAI's Jalapeño is a major signal. Also, look at novel applications of RL and diffusion models like the Princeton RIFC research. These techniques are breaking out of generative media. For investors, the AI talent war is a critical, non financial metric for tracking innovation potential. And while companies like Cerebras face market headwinds, the move to custom silicon by giants like OpenAI will reshape the entire semiconductor landscape. Finally, the unconfirmed report about Anthropic and government systems is a wild card. It points to a massive, high stakes market for AI in cybersecurity and underscores the profound safety and dual use challenges the entire industry is about to face. That's our analysis for today. The pace of this industry is relentless, and we're here to cut through the noise and give you the technical signal. If you find this valuable, subscribe to the channel so you don't miss our next breakdown. Thanks for watching.